Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Electronics and Telecommunication Department in Government Engineering College, Bilaspur, Chhattisgarh. From these lecture series, I am taking Signals and System, and up till now I have taken already 6 lectures, and this is the 7th lecture in Module 1. In Module 1, I am teaching the basic signals and classifications of signals and systems. So in last lecture we have completed almost even and odd signal. What are even and odd signal? We have seen already many things about it. So in this lecture I will be dealing with periodic and aperiodic signal. So let's get started, and we'll start our session with the signal that is called as periodic and aperiodic signal. Okay, fine. So see, the name suggests periodic means after a certain period it will be repeated. That is periodic signal. And aperiodic signal, which is for a finite period, it value is there or some value is there, but it doesn't repeat after a certain period. That is aperiodic signal. So let's see some example. We'll take one example or we'll do sine signal. Okay, so there is a sine signal. If you see sine omega t or sine 2 pi t, so it will be repeated till after 2 pi. Okay, so there is a time period of 2 pi. So this signal will start from here basic, and then again it will go on till 2 pi, and then again it will start. So you can see a set of some values which are there and which is repeated over and over. Okay, so the minimum time interval taken to repeat itself is called as fundamental time period. Okay, so fundamental time period is called as minimum time taken to repeat itself. And overall, if I say you what is time period, then you will say, sir, time period is integer multiple of this fundamental time period. Okay, so whenever it is a multiple, then it is a complete time period. Like 2 pi is there, how many 2 pi's are there in this sequence? This is also 2 pi, this is also 2 pi, so how many times it is repeated, that total that is called as time period. Okay, so see here fundamental time period, if you see fundamental time period is 2 pi. Okay, and if you see overall time period, you'll say some multiple is there, n into 2 pi, you can say. Okay, so this is time period. Now what are the properties of periodicity? Okay, so see, if signal is there ft, if you do certain kind of shifting operation, like suppose ft minus t, okay, or ft plus t, the signal will remain the same, the graph will remain the same, it doesn't affect anything. Like see, this signal is there, that is sine signal. Okay, signal is there, sine signal. So its time period is fundamental time period, its fundamental time period is 2 pi. Okay, so if it is shifted, see this time period, fundamental time period is 2 pi. So if you shift across 2 pi in the right hand direction or left hand direction, you will get the same graph. That this signifies that the signal or the graph which you are talking about is a periodic signal. So for periodicity, what we should see, ft should be equal to ft plus minus kt. Okay, so this is the mathematical expression for periodicity. So every periodic signal will have certain time of fundamental time period, and it will repeat it. So let's take some example. If we see sine of t, sine of 2t, okay, sine of 2t, sine of 3t, and sine of kt, let's suppose. Okay, so see here the fundamental time period, okay, fundamental time period will be equal to 2 pi by this is 1, so okay 1, so its fundamental time period is 2 pi. What we have seen this graph, uh, after 2 pi it was repeating, after 2 pi it was repeating, so we can write it down as like this. Graph is there and this is okay, so this was value 2 pi. Now when we see sine 2t, so fundamental time period will be 2 pi by 2, so it will come as pi. So now the graph will be like this. Okay, so its time period it will be, I will write it down in white, so it is pi and then 2 pi, so fundamental time period is pi. Okay, and then we'll go on again to sine 3t. Sine 3t is 2 pi by 3, so you can see that, and here fundamental time period is 2 pi by k. So you can see that in this both curve you can see that see this is covering its first cycle in 2 pi time period. It's this signal is covering its first time period in only pi time period, so you can understand that this signal may have or will have more angular velocity. Okay, more angular velocity, so that its velocity is more, that's why it is covering cycle in less time period. Okay, so you can generalize it as every signal has, sine signal has some angular velocity with which it is covering the cycle, so we can write it down as sine k omega naught t. Okay, and this omega naught is angular velocity, and fundamental time period will be 2 pi by k into omega naught. So sine signal will have, or sine omega naught t, cos omega naught t, these all are periodic signal. Okay, so let's talk about some complex valued signal, how they are periodic and non-periodic. So see, let's take an example of Euler signal only. So this is your Euler signal, and this can be represented as cos t plus j of sine t. Okay, now see, uh, if you take magnitude, let's suppose e to the power jt magnitude you want, so what you will do is cos square t plus sine square t equal to 1. Okay, and whenever you want to take e to the power jt angle, what you will do, imaginary part tan inverse of, okay, tan inverse of imaginary part by real part, so this you'll do, so you'll get it as t almost. So if you want to represent e to the power jt as magnitude and angle, you can represent as one angle of t. Okay, so see, this is a constant magnitude and this is time varying phase or angle. Okay, so whenever you want to calculate a constant magnitude means see, at t is equal to 0, if you will plot it as we want to see is it periodic or not, then we can see at t is equal to 0, t is equal to 0, cos 0 is 1 and sin 0 is 0, so the value will be 1 only. Okay, so the value is 1 means and angle will be 0, no problem, 0 degree angle will be there. So uh, this is 1 for t is equal to 0, angle will be 1 angle 0 degree. So we will take at this is center and this is our phasor, so this is t is equal to 0. Okay, and angle will be 0 degree. So when we take next t is equal to, let's suppose t is equal to pi by 2, we will take it as cos pi by 2 is 1, cos pi by 2 is 0, and plus j sin pi by 2 is something, so the value comes j, and j is nothing but 1 angle 90 degree. Okay, so we can see magnitude is 1 and the angle is 90 degree, means 90 degree is this, so 1 will be there, 1 angle 90 degree for t is equal to pi by 2. Now when we see at t is equal to pi. Okay, so cos pi will be there, see 1 pi by 2 and this minus 1. Okay, so value will come -1, and cos sin pi will be I think 0, pi by 2 and pi. Okay, value will be 0. So a value will come -1, you know, 1 angle 180 degree. So constant magnitude 1 will be there and angle will be 180 degree. So this will be there like this, t is equal to pi. Same with t is equal to 3 pi by 2, you will get it like that, t is equal to 3 pi by 2. And then when you will plot it as t is equal to 2 pi, you will again get this only. You can check it. So what I was telling that this signal e to the power jt, e to the power jt is also a periodic, and it repeats its value at after t is equal to pi by 2. This is a constant magnitude circle, and it is looking like ellipse, but consider it as a circle. And after at t is equal to 2 pi, again it comes back to its first position, and then again it will repeat. So e to the power jt is also a periodic signal, and if we calculate e to the power jt, what is the fundamental time period? So see, from phasor you can understand that after time fundamental time period of 2 pi, it is repeating itself again and again. So this is fundamental time period is 2 pi. But if you need to calculate for other signal like e to the power j of 2t, e to the power j of 2t, what will be the fundamental time period? So you can write it down as, if e to the power jt's fundamental time period is 2 pi, so whatever next signal will be there, multiple of that, you will divide it, so it will be 2 pi by 2. So the fundamental time period will be pi. Okay, so next e to the power j3t will be there. So what you will do, fundamental time period will be 2 pi by 3. Okay, so these all are signals whose fundamental time period can be calculated. So finally, if you calculate e to the power j omega naught t, which can be written as cos omega naught t plus sin omega naught t plus j sin omega naught t, so its fundamental time period will be equal to 2 pi by omega naught. So final output, what we wanted is the generalized expression for fundamental time period, that is 2 pi by omega naught. Same for the discrete time signal. The signal can be periodic or aperiodic based on the its sample. So let's talk about some discrete time signal. Discrete time signals. Okay, so discrete time signals, you know, we talk about number of samples. So let's talk about if it is in n and the m, this is amplitude. So let's talk about some samples. Is there, it is 1, it is 2 and 3. Again, if you find the same sample, set of samples after certain amount of time, so if you see the almost this 3 sample is repeated after and some sample. Okay, so you can say that the fundamental time period for this signal, this is periodic because this is a certain number of sample, it is repeating itself, so it is a periodic signal. But the minimum number of sample in this case, what will take fundamental time period is the minimum number of sample taken by discrete time signal, periodic signal, to repeat itself is called as fundamental time period. Okay, and it is generally denoted by n. Okay, capital N will denote as fundamental time period. Okay, so here if you say number of sample will be equal to 3, because after 3 sample the values are repeating itself, so the value are n is equal to 3. Okay, so finally n, the thing which you need to remember for discrete time periodic signal is n should be always integer value. Okay, this should be always integer value because it is actually measuring the number of samples, so it should be an integer value. Okay, so you can see examples, some of the examples like sin omega naught n. Okay, sin omega naught n, cos omega naught n, these all are periodic signals. Okay, and there are some samples repeat after a certain time of time period, it is repeating itself. So let's see, we'll take one example again, e to the power j omega naught n. This is you know, Euler's signal, so we'll write it as cos omega naught n plus j sin omega naught n. earlier, just now only we have proved it that e to the power j omega naught t is a periodic signal having fundamental time period 2 pi by omega naught. So you can put it out down here also. You can put you can check it of cos omega naught n plus j sin omega naught n is periodic or not, and what is its fundamental time period. It will come as 2 pi by omega naught only. Okay, so here also e to the power j pi by 4n, if you see, you will get as the fundamental time period you want is the fundamental time period which will take here is n is equal to r into 2 pi by omega naught. This r value is nothing but the value which will make this as integer, because n will be integer. So the r is the minimum value which will be taken for making it as integer, that is r. So ultimately the final formula which you have to remember, or you for checking a discrete time signal is periodic or not, with this, because the fundamental time period is this only. So let's do it. I think for e to the power j pi by 4n, if you want to see what is its fundamental time period, so 2 pi by omega naught, so pi by 4 will be there, so it will automatically come 8. So r here r value will be 1 because it is not required directly, n value is coming 8. So what it means that after 8 samples, this e to the power j pi by 4n will repeat itself. For other type of signal like e to the power j 3 pi n is there, so its fundamental time period will be n is equal to r into 2 pi by omega naught, and here 2 pi by 3 pi will be there, so it will come as 2 by 3. So r can be equal to 3, because when we will multiply 3 it will come as integer value, and that is called 2. So here r value can be 3, and this signal is periodic and having fundamental time period 2. If we say e to the power j 5 pi n, so here also n value will be n is equal to r into 2 pi by omega naught, and here r will be what I don't know, but 2 pi by omega naught first we have to do 5 pi, so 2 by 5, so r can be equal to 5, and it will come as again 2. So after 2 samples it will be repeated. So see, the main thing is there, like one more I will take you, e to the power j root 5, okay, pi n, okay, under root 5 pi n. So if you want to check it is periodic or not, so we'll see n is equal to r into 2 pi by omega naught. We will see r value will be there 2 pi by omega naught, it will be root 5 pi. So 2 by root 5 is there. You cannot take r is equal to root 5, it is not at all satisfying. So this signal will not equal to this signal is not periodic, it is not repeating, and it won't repeat anytime. So what is the conclusion is that if our e to the power j omega naught n, okay, if e to the power j omega naught n is not non-periodic, okay, like see here we have talked about many signal like e to the power j 3 pi n, 5 pi n, and root 5 pi n values there. So e to the power j omega naught, if e to the power j omega naught is n is not periodic, then see this value is equal to cos omega naught n plus j sin omega naught n, okay, this value is like that only. Then this cos omega naught n and sin omega naught n will also be non-periodic. If this is only non-periodic, then how can we can see that this value will be periodic? This value will also be non-periodic, okay. So in discrete time signal, in discrete time phasor or discrete time sinusoidal signal, if you say see sin omega naught t, cos omega naught t, this value are always periodic, but we cannot say that sin omega naught n and cos omega naught n will always be periodic, because these signals in discrete time signal, these signals will be periodic conditionally. What is the condition? Condition is n should be equal to r into 2 pi by omega naught should come as integer value. if this value is satisfied, this equation is satisfied, this n value is integer, then only we can say that this value r called r will be periodic. But in real in continuous time domain, these are always periodic only, these are always periodic only, they don't have individual condition that this should be periodic. But in this discrete time signal, individual periodicity condition is there, that sine omega naught cos omega naught n should be periodic if at all this condition will be satisfied. So if I say you that sine t, if I will tell you sine 2 pi t, even if I will tell you sine root 3 pi t, okay, this value I will tell you and I will ask you, is it periodic? Then you will tell yes sir, this is periodic because it is in continuous time domain, and in continuous time domain we should not see any property. But if you same thing I will tell you sine of n, sine of 2 pi n and sine of root 3 pi n, okay, these three conditions are there. Now here blindly you cannot say that sir this is periodic, okay, we need to check it. Like sine n is there, sine n, so its fundamental time period will be n is equal to r into 2 pi by omega naught, so 2 pi by omega naught will be equal to 2 pi by 1. So whatever r you can keep, you cannot make it as integer value. So this value, this signal is non-periodic signal. For this n is equal to r into 2 pi by omega naught, r into 2 pi by 2 pi, so this value will be 1. So overall this signal is periodic signal. This signal is not at all periodic because just only we have calculated like this, so this is also non-periodic. So now you can understand that what is the specific condition for discrete time signal and continuous time signal. There is no condition. So see, now the question arises, okay, for individual signal we have seen how to check it periodicity and how to check it is periodic or not. But if the signals are in combination, then what we can do, like sine of t plus sine of 2t, this signal is there. Now we need to check this signal is periodic or non-periodic. So what we can do, for combination of signals, the procedure to check it is periodic or not, because maybe this is individually periodic, it is individually periodic, but it is not necessary that combination will also be periodic, okay. So the condition is, see, it is having some time period t1, it is having some time period t2, okay. So if we take ratio of t1 by t2, it should come as rational number, the only condition rational number, okay. The condition for checking its periodicity can be written as t1 by t2 is rational number. And if you want to calculate complete time period, okay, if you want to see that what is the time period that these both signal combination will have certain time period after which this will repeated again and again, though time period can be calculated as LCM of t1 t2 and so on, whatever how much it is there, that much you can calculate. So see, basically we'll try to solve it with one question. Let's suppose I think sine t and sine 2t is there, let's check it is periodic or not. So time period t1 will be, I think t1 is equal to 2 pi by, I think sine t is there, so 1 will be there, so t1 is 2 pi and t2 will be equal to sine 2 pi by 2, 2 pi by 2, okay. So it is equal to pi. So if you do t1 by t2, t1 by t2 you will get as 2 pi by pi and this value equal to 2. So definitely it is a integer rational number, so you can tell it as the combination is periodic, obviously it is periodic. And now you want to calculate its time period, that how much time period after that it is repeating. So you can do it, t1 is equal to by t2 is equal to 2, so you can write it as t1 is equal to 2t2. So t is equal to t1, t1 is nothing but 2 pi, so you can write it as 2 pi, or 2 into t2, t2 is nothing but pi, so 2 into 2 into pi is 2 pi. So ultimately time period equal to 2 pi. So now you can say that this signal, this combination signal is periodic and its time period is equal to t is equal to 2 pi. So this can, by this method you can calculate your combination signal or periodicity. Okay, from see, now I have taken T is equal to LCM. I have taken this formula, T is equal to LCM of T1 to 2. You can also calculate, like, see, this is having some frequency omega naught, omega 1. Let's suppose this is having frequency omega 2. So if you want to calculate omega naught, okay, because after, if you want to calculate T, so T is equal to 2 pi by omega naught, you can do. So if you calculate omega naught also, you can calculate T. So T is equal to 2 pi by omega naught you want to calculate, omega naught you can calculate. See, this is having some frequency omega 1, omega 2. So this will be in some rational number. So SCF of all numerator and LCM of all denominator. This value, if you can calculate, then you can do it as omega naught, and from omega naught you can calculate your overall time period. Okay, so but when we calculate for discrete time signal, like same signal is there, sine of I think we'll take it as sine of n plus sine of 2n. Okay, so now the thing is that in continuous time signal we have not calculated that sine t is periodic or not, sine 2t is periodic or not. It is sinusoidal signal, it will be periodic. And but overall combination we have checked from this formula. So here we first, in discrete time signal, you need to calculate first. Whenever combination is there, you need to check first this signal is periodic or not, this signal is periodic or not. Okay, then only we can move forward. Okay, so first of all you need to calculate this one, that is n1. For n1 is equal to r into 2 pi by omega naught. So here r 2 pi by 1 value is there. So this signal is, I think, not at all periodic. So sine of n is not at all periodic signal. Sine of 2n, if you calculate n2 is equal to r into 2 pi by omega naught. So r into 2 pi by 2 pi 2. So it will be r into pi. Okay, I think yes. So r into 2 pi, so it will also be equal to r value will nothing, it will affect, so it will also pi, and this is also non-periodic signal. But instead of this, if we can write it as sine of pi n, okay, sine of pi n plus sine of 2 pi n. So we'll get as n1 is equal to 2 pi by pi, so it will come as 2, and n2 will be 2 pi by 2 pi, it will come as 1. So n1 and n2 is integer value, so it will be act as both are individually periodic. Okay, but both together will be periodic or not, again you need to calculate, like in continuous time domain only, n1 by n2. So n1 by n2, if you do 2 by 1, it will be rational number, then it will be periodic. So see, and whenever you want to calculate overall n, if you want to calculate, same procedure earlier what we have done, LCM of n1 comma n2 and so on. Okay, so two conclusion, at the last I will draw some two conclusion, is that whenever we do sum of two continuous time periodic signal, okay, whenever we do sum of two continuous time periodic signal, it may or may not be periodic. Okay, but sum of two the discrete time periodic signal is always periodic. Means what conclusion is that, understand it, sum of two periodic signal, continuous time periodic signal, okay, may or may not be periodic. It is based on this relation. If it is rational number, then it is periodic, otherwise it will not be periodic. But here what we have seen that when sum of two discrete time periodic signal, this is periodic signal, this is our periodic signal, and this is a periodic signal. So whenever we add two discrete time periodic signal, the sum will be always n1 by n2 will always come rational number only. It is not a value that to check, but it will come always periodic when both are always periodic. This is first conclusion which we have to draw it. Second conclusion is that when two continuous time sinusoidal signals or phasors are added, they're individually periodic. Okay, if they are individually periodic, ratio is only with the periodic nature of the combination, because combination nature we need to see. Whereas when two discrete time sinusoidal signals are added, ratio is with their individual periodicity. Means here we are calculating its periodicity, but earlier we used to calculate for continuous time signal overall periodicity, है ना? So this is the difference between discrete time signal and continuous time signal. Rest I think by this lecture you will be able to solve many questions regarding periodic and aperiodic signal, and in both domain, time domain, and discrete time domain and continuous time domain, and as well as for complex signal also. So in the next lecture we'll see what are the energy signals and what are power signals, and if time permits we'll also see some more type of signals. So for this lecture this much only. We'll meet in next lecture. Till then, tata, bye bye, see you, have a good day.